Yes. Uh, so today we are going to see a new topic, that is classical encryption techniques. So which is an important topic in our first unit. Okay. So we have some two important questions from the first unit. One is OSI security, network security architecture. So we have seen that network security architecture in that yesterday's class itself, and today we are going to see some concepts about that classical encryption techniques. So all of you know about that encryption and decryption, I hope, right? So Yoga, what do you mean by that encryption? Yoga Prakash from CSE, what do you mean by that encryption? Yes. Anybody else? So what do you mean by that encryption and decryption? Hello. So we can start now. Uh, so today we are going to see something about encryption and decryption. That is classical encryption techniques. So I hope all of you know about what is encryption and what is decryption, right? And anybody can answer what is encryption and what is this decryption. Yoga Prakash from CSE. So, can you differ that encryption and decryption? What do you mean by that encryption and what do you mean by the decryption? First, am I audible to you all? Yasikimuthu, am I audible to you?
Yes, sir.
Okay,
Yes, sir. Yes.
okay. So, no answer from your side, right? So, what do you mean by that encryption? So, conversion of your original data into some other format is known as encryption. And what do you mean by that decryption? The vice versa. That converted data is again back to that original data. That is called a decryption. Okay. So, these two things are. Who's that? Please unmute yourself. Okay. So, what I'm yeah, classical encryption techniques. Okay. So, in that cryptography network security, two things are very much important. One is encryption and another one is decryption. So, till the fifth unit, the sender sends a message to that receiver. The same thing is going to be happened. The sender sends a message to that receiver. That message will be encrypted by using some algorithm. That encryption is nothing but to protect that data with that intruders, right? So till the 5 units we are going to see the same concept, right? But the algorithms are different. So from the basic to till the advanced algorithms we are going to discuss in our subject, in our first unit, I mean in our subject, right? Cryptography and network security, right? So from in that first unit we have some basic techniques for encryption and decryption, that is called the classical encryption techniques. In this classical encryption techniques, so we can differ that classical encryption techniques into two types. Okay. So first of all, what is mean by the classical encryption techniques? So it's just an opposite of modern cryptography. Nowadays the algorithms are somewhat high comparing to the previous one, right? But now we are going to see some basic algorithms, some of the basic encryption techniques from the base. So what are the techniques we have used in the previous days? What are the techniques we are used in that ancient days? So we are going to see that techniques, right? So classical encryption techniques is nothing but it's an opposition of modern cryptography. So what is the goal of that classical encryption technique is to introduce basic concepts and terminology of encryption to prepare us for studying modern cryptography. Okay, so it will give some how to say, it will give some interest to learn that advanced techniques in that network security, right? So as I already told, classical encryption techniques has two types. One is substitution technique and another one is transposition technique, right? So before entering into that, what do you mean by that substitution and what do you mean by the transposition? In that name itself, the substitution technique is nothing but if your data is need to be encrypted that data will be substituted by any other letters. For example, if you have data in that alphabetical order, for example, how to say, your name is a data, your name is a plain text, okay, so you just want to convert it into some other format, you just want to encrypt your name, okay, so in that substitution technique, the every letters in your name will be substituted by some of the other letters which is not in your name. Clear? So that is called as substitution. But in the case of transposition is nothing but you just transfer, you just how to say, move that letters within your name itself, okay, so that is called a transposition. There is no new letter will be takes place in that original text, so that is a transposition, that is a substitution. Clear? So transposition is nothing but conversion, changing the positions of the letters, that is called a transposition. But substitution in the sense you can substitute that letters with some other letters which is not in your text, plain text, okay, so this is a major difference between a substitution and transposition. Clear? Okay, what are the basic terminologies we are using in this concepts? Okay, so in that first class itself we have discussed, I hope, right? Plain text is nothing but our original message. Cipher text is nothing but encrypted message. Encrypted message is in the sense converted message, okay, so that is a cipher text. Enciphering, that is, or encryption or encipher. So we have two names for that: encryption or encipher. Encryption is nothing but conversion of the original format into some other format, that is a encryption, okay. So encryption algorithm is, what is the algorithm you have used to encrypt your data, that is a encryption algorithm. Clear? That encryption algorithm will be from the base to that advanced algorithms, okay. So from the base itself we are going to see some of the basic algorithms for encryption, and from the second unit we can further see some of the new advanced algorithms for encryption of your data, right? Encryption is nothing but the encryption algorithm is nothing but the algorithm which is used for encrypting your data, that is converting your data, that is called an encryption algorithm, okay. That encryption algorithm has two things: plain text and secret key. So plain text in the sense your original data, secret key in the sense the key or the data which is used for converting your plain text, that is called a secret key, okay. So we can explain the secret key with an example further, right? Okay, so what is meant by before that we have some two different things. One is symmetric cipher model and another one is asymmetric cipher model. So what do you mean by that symmetric cipher model? Is in the name itself, symmetry means if you have plain text here, so that plain text is going to be encrypted by using some of the algorithms. So this is one of the advanced algorithms in which we can see this in our second unit, right? So in this diagram they have encrypted with an algorithm called DES, okay, so by using some secret key. Clear? So that data has been encrypted. Now that plain text is converted into cipher text, okay. That cipher text has sent to that receiver side, okay. So in that receiver side, the receiver received the transmitted cipher text. Clear? The receiver received that cipher text. By using that cipher text, how they can read that original message means that cipher text is going to be decrypted. Decrypted means that converted data is again going back into the plain text, okay. So that conversion of that encrypted data, okay, so that is called a decryption, right? So the decryption takes place in that receiver side. Here for the decryption the same secret key is used, okay. So for both encryption and decryption the same secret key is used, that is known as symmetric cipher model, right? So same key is used for both encryption and decryption, that is known as symmetric cipher model, okay. So what is called a decryption? Already told that converted data is going back to a original text, okay. So that is called a decryption. And decryption algorithm, what is the algorithm we have used for that decryption, okay. So secret key is the key which is used for both encryption and decryption, that is called a secret key, right? Okay, so these are some of the important terminologies in our network security. So in the first class itself, we have discussed about that. Cryptography is nothing but a science of studying ciphers. Okay, so cryptanalysis is nothing but attacks against cryptographic systems. The science of studying attacks against cryptographic systems. Okay, so what are the attacks and how the attacks are going to affect the systems? So these are some of the studies. Okay, the cryptanalysis is nothing but analyzing the concepts of attacks and other things in that systems. That is called a cryptanalysis. Okay, so cryptology is study of that cryptography and cryptanalysis, right? Okay, so symmetric cipher. What do you mean by that symmetric cipher? Symmetric cipher is nothing but the same key will be using for both encryption and decryption. Clear? Okay. In that symmetric key, we have two types again. One is block cipher, another one is stream cipher. Okay. So what is called a stream cipher and what is called block cipher? First thing. Okay. We can explain by further with an example, right? So just keep it in mind. We have two types in stream cipher and block cipher. Okay, enough. Asymmetric cipher. Asymmetric cipher is nothing but using different keys for both encryption and decryption. That is a vice versa of that symmetric cipher. Clear? So that is called a asymmetric cipher. Okay. So these are some of the story. Symmetric encryption. Symmetric encryption is the same key is using for both encryption and decryption. Just leave it. Okay, so cryptanalysis. What is called cryptanalysis? The study of attacks about that cryptography. Hello. Okay, so we can continue. The study of attacks is known as cryptanalysis. The analysis how the analyzing the concepts behind the attacks in that systems. That is called cryptanalysis. And Kirchhoff's laws. It is an important 2-mark question in your first unit. Kirchhoff's laws is nothing but adversary know all details about the crypto systems except the secret key. Kirchhoff's principle is nothing but the cryptanalyst will knows all the details about the particular system except that secret key. So who is called a cryptanalyst is the person which is the person who is trying to break the security of your system is known as he is called as cryptanalyst. Okay, okay, so for the cryptanalyst he can know everything about your system except that secret key. That is called Kirchhoff's principle. Clear? So the two things are there: general approaches, brute force attack and non-brute force attacks. So what is called brute force attack? We have already experienced or experimented in this brute force attack. Okay, so we have already did that, but we don't know this is known as brute force attack. Okay, so what is that means? If you want to find a password of your friend's mail ID, or if you want to find a pin number of your friend's mobile, okay, so you are just trying all the possible sequences, you are just trying all the possibilities. That is his birth date, his register number, his favorite actor, his favorite actress, his best friend or his best girlfriend. So whatever, what are the things I know about him, I just trying all the things. That is called a brute force attack. Okay, so trying all possibilities to break the security of your friend's mobile or friend's mail ID, that is called brute force attack. Clear? Okay, so not brute force attacks means by using some algorithm, some techniques, that is called non brute force attacks. Clear? Okay, so brute force attacks, how many possibilities are there? Okay, so for example, if your friend has some 8 letters of how to say, if your friend's password contains 8 letters, so 8 factorial possibilities are there, correct? Okay, 8 factorial possibilities are there. That's why all the mail ID, all the Gmail account also, and even our Outlook account also, the password will be very strong. For that we can combine that alphabetics, numerics and alphanumeric characters to secure our data from that brute force attack. Okay, so this is the reason behind why all the passwords should be strong. In some of the websites it shows your password is strong, I mean your password is weak, you just use both alphabetical, alphanumeric, numeric symbols. Okay, so they pop up that message like that, right? It is because of this brute force attack. Clear? Okay, so next, cryptanalytic attacks. So what are the types of cryptanalytic attacks? What is mean by cryptanalysis? It's a study of attacks, right? It is a study of attacks. Okay, now cryptanalytic attacks. This cryptanalytic attacks will be used by the cryptanalyst. Cryptanalyst means some hacker. We can name him as hacker. Okay, the hacker will have these four possibilities: ciphertext only attack, known plain text only attack, chosen plain text only attack, chosen ciphertext attack. Okay, so these are the four types. They are going to how to say, experiment. Clear? Okay, ciphertext only attack. Ciphertext only attack means he got only the ciphertext, that is converted data. By using that converted data, he wants to know what is the original data. He will try all the possibilities to convert the ciphertext. Okay, that is a ciphertext only data only attack. Second one is known plain text attack. Known plain text attack is nothing but how to say, so our data will not be moved as a stream. Clear? Moved as a continuous one. It will be converted into some of the packets. Clear? So each packet contains a part of a particular message. Clear? So he can collect that packets. He can collect that packets. In that packets, he will rearrange. He must rearrange to read that original text. Clear? So that is a known plain text attack. He has some data. He has some plain text, but he wants to rearrange that one. Okay, so after that correct rearranging, after that perfect rearranging, he will get what the data is exactly. Okay, so that is a known plain text attack. Chosen plain text is he can randomly collect some of the plain text. Okay, some of the contents. Okay, so after collecting that, he can assume this is that data, this is the original message. It's just an assumption. Clear? How many are there? Maulishwaran, you are there? Maulish from CSE.
Yes, sir.
Okay. Are you clear with that? Any doubt?
No, sir. Clear, sir.
Okay. Okay, guys, if you have any doubts, you just put it as message in your chat box. Correct? So once the session over, we can clear all the doubts.
Sir,
Who's that?
sir, class கொஞ்சம் ஸ்பீடா போற மாதிரி இருக்கு, கொஞ்சம் ஸ்லோவா பண்ணிக்கலாம் சார்.
Naresh, என்னமா?
எஸ், கிளாஸ் கொஞ்சம் ஸ்பீடா போற மாதிரி இருக்கு, கொஞ்சம் ஸ்லோவா பண்ணிக்கலாம் சார்.
அப்படியா? சரி, ஓகே, ஸ்லோ பண்ணிக்கலாம்.
ஓகே சார்.
ஸோ இதுக்கப்புறம் இது ஜென்ரல் கான்செப்ட் தான். இதுக்கப்புறம் ப்ராப்ளம்ஸ் இருக்குது. ஸோ அதுக்காக தான் கொஞ்சம் போகிறோம். சரியா? ப்ராப்ளம்ஸும் நம்ம ஸ்லோ பண்ணிடலாம். ரைட்?
ஓகே சார்.
ஓகே. Okay, so we'll continue. Okay, so these are some of the examples of chosen plain text. Clear? Right. Now coming into our topic, that is classical encryption techniques. Okay, so we have two types in that classical encryption techniques. First one is substitution cipher and another one is transposition cipher. The third one, product cipher, is not in your syllabus. You can just know about it. That's it, right? Okay, so what is called the substitution cipher? Substitution cipher is nothing but, as we already told, if your name is your plain text, you want to convert your name is a original data, you just want to convert it into a ciphertext, that is converted data. Okay, excuse me. Okay, so substitution cipher is the letter, the alphabetical letter in your particular data will be substituted by any of the letters. Okay, so some other letters, that is called substitution cipher. Okay, so we can explain it by an example. So in that substitution cipher, we have 5 types. Okay, so you just note it down. Sorry, we have 6 types. You just note it down. Number 1 is Caesar cipher. Do you all have that paper and pen with you now?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Right, wait a minute. Okay, right. So first thing, substitution cipher. Substitution cipher, we have 6 types. Number 1, Caesar cipher. Number 2, mono alphabetical cipher. Mono alphabetical cipher. MONO alphabetical. ALPHABETIC alphabetical cipher. Third one, Playfair cipher. Playfair cipher. Fourth one, Hill cipher. Hill, HILL, Hill cipher. Fifth one, poly alphabetical cipher. Polyalphabetical cipher. That polyalphabetical cipher is also known as Vigneer cipher. Okay, you just leave it. Polyalphabetical cipher, you just note it down. And that last one is one-time pad. The last one is one-time pad. Before that, I want to ensure that whether my face is shown to you all.
No, sir.
No, but I now
Okay.
now
Sir.
தெரியலையா?
தெரியல சார்.
என்னையா கேமரா ஆன்ல தான் இருக்கு. சார் ஹலோ,
இப்போ ஸ்கிரீன் தானா ரிப்ளை இதாயிட்டு இருக்கு.
அப்படியா? இப்போ என் கேமரா அப்பையிலேருந்து ஆன்ல தான் இருக்கு, பட் தெரியலையா? பட் எனிவே தெரியல. ஸோ ஓகே, we'll check it out later, right? Okay, now we came to 6 types, right? Substitution cipher, we have already 6 types in that, right? First one is Caesar cipher, second one is mono alphabetical cipher, third one is Playfair cipher, and fourth one is Hill cipher, and the fifth one is polyalphabetical cipher, and the last one is one-time pad, right? So we have 6 types in that substitution cipher. Okay, so what is the first one? This is the basic cipher technique. This is the basic encryption techniques. Our network security starts from this only. Our network security encryption techniques is going to be started. This is the basic technique, right? So this Caesar cipher was introduced by the Julius Caesar. I think you are all know about Julius Caesar. He is a famous king, right? So Julius Caesar invented this Caesar cipher, right, to deliver his message to their soldiers, to their commanders, without known by any other parties. Okay, so he used this technique. Okay, so first thing, all of you write down that A to Z in your paper. A to Z, A B C D till Z. Now write it fast. I hope you all know, you all remember that alphabets, right? A to Z. Finished? Finished?
Yes, sir.
Okay.
Yes, sir.
And number it. A is 0, B is 1. So Z will be 25, correct? Number it. Number your letters. A is 0, B 1, C 2, D E till Z. Finished? Finished? Okay. Right. So this is the starting one, right? So your Caesar cipher. What is mean by Caesar cipher is write your name first. Just write a heading as Caesar cipher. In that Caesar cipher, plain text will be your name. Just plain text. Write it as plain text equals your name. Finished? Okay. Now cipher text. Second one, cipher text. You are going to convert your name into a cipher text, your plain text into a cipher text. Clear? Right? Okay. So what happens in that Caesar cipher is your first letter will be replaced with, your letter will be replaced with third position from your letter. Okay. For example, if my name is, if my plain text is Praveen, my name is Praveen. So Praveen, right? So I'm going to convert this original plain text into cipher text by using Caesar cipher. Clear? In that Caesar cipher, what is the conversion is the letter can be substituted. The letter can be substituted with the third letter from the original letter. For example, if first letter is P, P is my letter. What is the third letter from P? Q or S. So P can be replaced as S. Clear? Clear?
Yes, sir.
Okay. So P is replaced with P is substituted as S. Okay. So what is R? Second letter is R. So now R can be replaced with, R can be substituted with, what is the third letter from R?
U.
U. Correct. What is the third letter actually in our plain text? A. P or A. So now A can be replaced with, substituted with,
D.
that is it. That is it. This is known as Caesar cipher. Clear? Okay. பேசிட்டா
Okay, sir.
ஓகே ஸோ பேசிட்டா கொஞ்சம் அன்மியூட் பண்ணிடுங்களேன், காது கொய்யுங்குது. ரைட். ஸோ right, so this is known as Caesar cipher. Caesar cipher is nothing but your letter in your particular data, the letter will be replaced with third position. Okay, so if my letter is P, it can be replaced with Q or S. So just just check it with your name itself, your name itself. Okay, so this is known as Caesar cipher, right? Now just analysis for this Caesar cipher. Okay, so we have told that basic concept of Caesar cipher. Okay, now we can analyze through a technique, we can analyze through a document, right? So the general Caesar cipher, here C is known as cipher text and P is known as plain text. Clear? E is called as encryption and D is called as decryption. Okay, for getting cipher text, the formula is C equals P plus K mod 26. Okay, now this is the formula, right? Now you just substitute that value from your plain text and from your ABCD, that alphabets. Now you just substitute it. Okay, so for example, my first letter is Praveen la first letter na P. Okay, so what is the value for that P? நீங்க அந்த ABCD ல கீழ 0 to 25 எழுதிப்பீங்களா? What is the numerical value for that P?
15, sir.
15. Clear? Okay, so P value is 15 here. P value is 15. Okay, and what is the key I am using here? That key is that plus 3 na cipher text. In that Caesar cipher, the third position will be take care, right? Who is that? You just unmute, please. Are you clear with that? Right. So what is k? K in that Caesar cipher, the k value will be 3 because in the technique itself, the third letter from that sorry. Okay, the third letter from that plain text will be replaced, will be substituted, right? So the k value will be 3. Okay, so p value is 15 plus k value is 3. 15 plus 3, 18. Correct? Correct dana?
Yes, sir.
Okay, so 18 mod 26. C is nothing but 18 mod 26. So what is the functionality of this mod 26? What is the purpose of this mod 26 is mod 26 is nothing but a division operation. Okay, so after dividing, what will be the remainder? That is a mod function. Mod function oda purpose enna to find a remainder by dividing the original data. For example, if p plus k the munadi irukadhu vandu, if that addition will be some 27, you just keep it at. If addition will be 28, means 28 mod 26. Okay, so the value for c is 28 mod 26. You are going to divide this 28 by 26. So 28 by 26, now what will be the remainder? 2. Okay, so the 2 will be the output for this mod 26 value. Are you clear with that? Clear? Okay, so this is a very important one, right? Okay, now it's 18 mod 26. That 18 will be, that 18 is smaller than this 26. Okay, so I can directly take this value. Okay, I can directly take that 18 value. Okay, so now what is alphabet for that number 18?
Yes, sir.
Yes, p can be substituted with yes. Okay, this is the formula. Clear? So are you clear with that Caesar cipher?
Yes, sir.
Okay, so plain cipher na minus பண்ணணும், இது ரிவர்ஸ்ல போகணும், அவ்வளவுதான். Okay, so this is known as Caesar cipher. Clear? And second, who is that? And second technique. Okay, so second technique என்னமா? Okay. Okay, so this is the first thing. Caesar cipher gets over. Second one is monoalphabetic cipher. Okay, so what is called monoalphabetic cipher is, it is just a advanced version of Caesar cipher. Okay, now you learnt about that Caesar cipher. What is the drawback in the Caesar cipher? What is the advantage and disadvantage of that Caesar cipher? யார கேட்கலாம்? ஜெயவர்தன். ஜெயவர்தன் இருக்கியா? ஜெயவர்தன் from CSE. ஸோ கிளாஸை மட்டும் ஆன் பண்ணிட்டு இங்கேயே போயிட்டாரு தலைவர். சரி, ஓகே, நெக்ஸ்ட் விந்தியா. விந்தியா ஃப்ரம் CSE. விந்தியா அன்மியூட் பண்ணுங்க. நீங்கள் மியூட் பண்ணி பேசிட்டு இருக்கீங்கன்னு நினைக்கிறேன். அன்மியூட் பண்ணுங்க. ஓகே, எனிவே அவங்க லைனில் தான் இருக்காங்க, பட் அன்மியூட் பண்ணலை. மியூட் பண்ணியே பேசிகிட்டு இருக்காங்க. ஐடியில் ஸ்வாதிகா. ஸ்வாதிகா Shwatika also not here, right? Right, one thing I want to tell you guys, நாங்கள் இங்கே வேலை இல்லாமல் கிளாஸ் எடுத்துகிட்ருக்கல, சரியா? ஓகே, ஸோ ஆல் ஆர் ஒர்க்கிங் ஃப்ரம் ஹோம். Okay, so even though we are taking classes for you by preparing something, right? So I think it is not fair thing. You just இப்போ அட்டண்டன்ஸ் வருதுங்கிறதுக்காக வெறும் ஆன் மட்டும் பண்ணி வச்சுட்டு போகிறதுல என்ன யூஸ்ன்னு எனக்கு தெரியல. ஓகே, ஓகே, லெட் மீ சி. ஸோ நம்ம கடமை right? So second type is monoalphabetic cipher, right? So in this Caesar cipher, we have seen some technique in the Caesar cipher, right? So what is a who is that man? பிரீத்தி அன்மியூட் பண்ணுங்க. ரம்யா தேவி அன்மியூட் பண்ணுங்க. Okay, anyway, so what is a drawback in that Caesar cipher is we just substituted that letter which is third position from that original letter, correct? Okay, so that is a major drawback in that Caesar cipher, right? So any drawback abdina, by using the Caesar cipher, a can be substituted only by d, okay? The same will be b can be b can be substituted with only by e, not by any other letters, okay? So it will be more easy for that intruders, it will be more easy for the third parties to retrieve their messages, to retrieve the original messages. So there is no security behind that. So that is one of the major drawbacks in that Caesar cipher. That is, a can be substituted only by d, not by any other letters. B can be replaced only by e, not by any other letters, okay? So that is a drawback in that Caesar cipher. To overcome the drawback, the next technique came. That technique is known as monoalphabetic cipher. In this monoalphabetic cipher, a can be replaced with any of the remaining 25 characters. It can be replaced with d, it can be replaced with k, it can be replaced with f, any other letters, okay? But that substitution will be known both by the sender and the receiver. They too must have a chart, right? A can be replaced with any other letters, right? So this is known as monoalphabetic cipher. Clear? So this is the major difference between the Caesar cipher and monoalphabetic cipher, okay? So this is some of the some of the advanced version of the Caesar cipher. Clear? Okay, so this is the one, okay? So how the monoalphabetic is advanced comparing to Caesar cipher, right? So it has 26 factorials to derive that original data, right? So 26 different factorials are there, right? From that Caesar cipher, in that Caesar cipher, only some minimal amount of possibilities are there, but in monoalphabetic cipher, there is huge numbers we want to try to get the original data, okay? So this is a monoalphabetic cipher. Don't worry, we don't have any problems in that monoalphabetic ciphers. Okay, so these are some of the stories. And the third one is play for cipher. In that before some 10 slides, we have told about that stream cipher and block cipher, okay? So what is called a stream cipher and what is called block cipher? In that slide we have told in future we'll discuss about that, right? Okay, so what is called a stream cipher and what is called block cipher is, in that Caesar cipher and also in that monoalphabetical cipher, we can convert or we can encrypt the data one by one letter by one letter, okay? One letter to one letter, okay? So one letter to another letter means
Okay, sir.
okay, so one letter to another letter means, for example, in that Caesar cipher, our name, okay? So first letter P, so P can be substituted with any other letter. Second number R can be replaced with one letter, R can be substituted with one letter. So we have taken this as a letter by letter or a letter by letter, word by word, okay? So that is known as stream cipher. But in the form of block cipher, I can take my data into a blocks, in that blocks, okay? For example, Caesar cipher and monoalphabetical cipher, one letter, okay, one by one I have taken, okay? So that is called a stream cipher. Block cipher means if I have some 6 letters, means the same example, Praveen, I have taken that plain text as Praveen, okay? So here, instead of taking one letter, I can segregate that plain text into number of blocks. Each blocks contains some 2 letters. PR is a one block, AV is a one block, EE is a one block, like that, okay? So I can take that input as a blocks, Okay. So for that remaining 4 types we are going to use that block cipher model. Okay, so now play for cipher. In this play for cipher again, you have some basic rule for this play for cipher. Okay, so all of you hello, hello,
எதுக்கு
hello, mute பண்ணுங்க யாரு. Okay, so all of you, you just draw a 5 cross 5 matrix like this. 5 cross 5 matrix, you just draw all the things. Now 5 rows and columns, 5 rows and 5 columns. Okay, finished.
Yes, sir.
Okay.
Yes, sir.
Okay, the problem will be given as,
Yes, sir.
okay, so how the problem will become in that play for cipher is by using play for cipher, just encrypt the data. Some data will be given by also the key is some key will be given here. So here I have derived a problem to explain you. Here our problem is I just want to convert that plain text into ciphertext. That is, I want to encrypt that given data. So here the plain text is instruments. Okay, so instruments is a plain text I have given, right? And also the key also is given. Okay, the key also given. So key is monarchy. Okay, so the key will be differ in your in some in last year question paper. The key was how to say, the key was monarchy, but the plain text was Swaraj is my birthright, right? So they have given the plain text as Swaraj is my birthright. By using that key and also by using the play for cipher, I want to convert that particular data, convert that plain text. Okay, right. So coming to our problem. So the key was given as monarchy and the plain text was given as instruments. Okay, first I want to draw 5 cross 5 matrix. Okay, so and in that first row, the key was given now. So that key should be written. So monarchy is a key. I just written MONARCHY. So first that should be written. Clear?
Yes, sir.
Okay, so in that remaining things, you just fill that remaining letters in that alphabets. Okay, so one question is, I have 26 alphabets but we have 25 boxes only, correct?
Yes, sir.
Okay,
Yes, sir.
the class எடுத்துருக்கோம், அந்த டிவி எல்லாம் கொஞ்சம் ஆஃப் பண்றது. Okay, anyway, okay, so we have 26 letters but we have 25 box here, right? So for that you can place that I and J in that same box, I/J, because I and J has a same frequency. So you can write it in a single box. Clear? Okay, so all the remaining letters has been filled, right? Right,
sir.
okay. Now so now I have a key and also the remaining letter has been filled in that 5 cross 5 matrix. Okay, now the encryption is going to be takes place. Okay, so we have 4 steps here in our encryption and decryption. We have 4 steps here. If a pair is a repeated letter, insert filler like X. That is, if you have the same letters in that plain text. Okay, so like we have instruments here, right? So we have 2 T's here. Sorry, this is not a one. Okay, so wait a minute, this is not a one. If you have 2 letters like this. Okay, so double T or here. Okay, so once you here you just want to split this plain text into two things. Okay, into number of blocks, and each block must contain two letters, right? Okay, so for example, this instruments as segregated into like this. Clear? Okay, so two things: in is one block, st is one block, ru is one block, me is one block, nt is one block, and z is a separate one. Clear? Okay, so here if some letters are repeated like this, tt or nn is repeated, means you can split this as, if two t's are there, you can split this as tx and xt, like this. If two letters are the, if you once you started to create a block, if one block contains the same letter twice, you can segregate as tx and xt. Clear? This is rule number 1.
Okay, sir.
Okay, rule number 1. And next one is, here z is individual, z alone takes part in that last block. Okay, so for that I can add x here. Clear? Okay, so this is rule number 2. Now what is another thing? If both letters fall in the same row, replace each letter with the letter to its right. Okay, so I can explain by this example, right? So what is first two letters in our instruments? What are the first two letters?
I-N.
I-N. Okay, so take that I and N. Show, just show your diagram where is I and where is N. Okay, so here in our chart, in our matrix, I is here and N is here. Okay, so what are the other things which are parallel to I and N? For example, here is I, here is N. So what is common to this I and N? A. And what is common to I and N? G. You just
G.
you just draw a box like this. You just draw a box like this. Okay, so now this IN can be substituted as AG or GA, any other form, AG or GA, that is not an issue. Okay, so now that IN has been substituted as AG, so I can take as AG, anyone, AG. Clear? So this is the first one. Okay, so now IN chapter over. IN has substituted as GA. So now what is the second letter? IN. What is the second block?
ST.
ST. Okay, so look at this. ST. Where is S and where is T? Okay, so two are in that same row. So two letters are in that same row. If two letters are in that same row, the substitution will be the next letter of that original letter. That is, S can be replaced with T and T can be replaced with next letter. If it is last one, go to that first one. Clear? If S can be replaced with T and T can be substituted with that next letter, that is L. Clear? If two, for example, if P and Q are in the same row, so that is a plain text. For example, I am telling, so if P and Q are that plain text, P can be replaced with Q and Q can be substituted with S. That's it. Clear? Okay, so IN ST is over. What is the third one? RU, correct?
Yes, sir.
Okay, so show the you just see that where is R and where is U. So here are the two things, where is R and where is U. So these two are in that separate columns. Okay, so just show what is parallel to these two things, R and U. What is common thing? M. R and U. What is common thing? Z. So that RU can be replaced as MZ or ZM. Clear? Okay. So now RU over,
Yes.
IN ST over, RU over. What is the last one? IN ST RU ME, correct? ME, right? So ME are in that same column. Clear? So for that same column or for that same row, what is the procedure? it can be substituted with next letter. For example, ME are in the same column, so M can be replaced with C and E can be replaced with L. So that ME is substituted as CL or LC anyway. Clear?
Yes, sir.
Yes, sir.
Okay, so like that the remaining happens. Okay, so other two things are the same thing. Okay, now what is your plain text? You just written in your paper now. What is the plain text for that? Sorry, what is the converted text, that is ciphertext for that instruments? Anyone just read it out?
AG,
Hmm.
AG,
Hmm.
TL, MZ,
Okay.
LU,
Okay. So LC or CL.
LC, sir, LC.
Hmm. And what are the two remaining two things? So you are going to draw a table or draw a box. Okay, so just find that what is parallel to both things and what is common to these both things. Okay, it will be RQ and XT. Clear? So this is known as play for cipher. Is there any doubt in that?
No, sir.
Okay, shall we proceed to next one? So next
Yes,
one
sir.
is Hill cipher. Okay, so Hill cipher in the sense, so it will be asked in that 16 mark question. It's also okay. So because it is somewhat it's not so tough, but it's somewhat tricky one, right? So Hill cipher. So Hill cipher in the sense, you are going to you are going to encrypt your plain text by using the key. Okay, so till now the key value in that plain text, the key value was monarchy in the sense, in the word as a word or as a sentence they have given a key, right? But in that Hill cipher the key value will be in the form of matrix. Clear? In the form of matrix. So we can solve this Hill cipher now. So what is the formula for Hill cipher? Means C equals KP mod 26. If you need, you can write it down. C equals KP mod 26. Right? So C is called as ciphertext, P is called as plain text, K is nothing but key. So this is the formula, C equal to KP mod 26. Okay. Right. So here the input is, that is plain text, is ACT. This just for an example. ACT is a plain text example. Okay. The key value is GYB NQK URP. This is a G value, that is K value. Okay. So you have doubt, you may have doubt. So sir, you told like key should be in the matrix format, but here is a alphabetical one, right? Okay. So you want to write down the matrix format by using this key, by using this alphabets. Okay. How is, so the step to write a matrix is here GYB is in the first row, NQK is in the second row, URP is in the third row. Clear? You just write it like that. 3 cross 3 matrix. In this 3 cross 3 matrix, GYB should be in the first row, NQK should be in the second row, URP should be in the third row. Clear? Now you just convert that original value into a numerical value. Okay, so what is the value for G? So you are already written now A0 B1 like that. So what is the value for G? 6. What is the value
J,
for
6.
இன்னும் சீச சைஃபர் விட்டு வெளில வரல போல, யார் இது? Sure, okay, anyway, so this is Hill cipher. You want to write the numerical value of the G. Okay, so G is 6, Y is 24, B is 1, like that. You just replace that words by that numerical values. Okay, now I got a yaar ye adu unmute பண்ணுங்க. Who's that? Who is that? Unmute yourself. Okay, so now you got some key matrix value. Clear? Okay, so this is K value. What is the formula for Hill cipher? C equals KP mod 26. Okay, so here this is K. Sorry. Okay, so this is K. And plain text. What is plain text here. A C T is a plain text here. Okay, so A, what is the value for A? 0. What is the value for C? I think 2. Correct? 2. What is the value for T? 19. Okay, so you just write it down like this, 0 to 19, right? Just now you do that matrix multiplication. First row column, first row, second row, and multiply, third row and multiply. You will get some. All of you know that how to say? All of you know that matrix multiplication, right? I hope so. So multiply this with 0, you will get 0, plus multiply these two things with 2. 2 into 6, 12, plus 48, 12 plus 48 plus 2. Okay, so add all the things, 222, 19 into 6 plus 19 into 24 plus 19 into 1, add all the things, 319. Okay, so after multiplication you got like this, right? So what is the formula? C equals Kp mod 26. Mod 26 in the sense you are going to divide this 67, 222 and 319 with 26, and mod 26 is nothing but what will be the remainder. So I can add that remainder, I can take that remainder. This is the functionality of that mod 26. Okay, for example, 67 is divided by 26, so what will be the remainder? 15 is the remainder. So 222 divided by 26, what is the remainder? 14 is the remainder. 319 divided by 26, what is the remainder? 7 is the remainder. Okay, now I got that remainder value. Again I am going to check what is a alphabet, parallel alphabet for this number 15. What is it? You just go and check. For 15, what is the letter?
P.
P for Praveen. P.
That Praveen, sorry, that P for Praveen, sir.
Okay. Sorry. For what is 14?
O.
Oh, 7?
O for omelette. 7 is H, sir.
H. So your ACT is converted into POH. Clear? Clear?
Yes, sir.
Yes.
Clear,
This,
sir. Clear, sir. Clear,
yes,
sir.
yes. This is known as Hill cipher. Okay. And do you have any doubt in that Hill cipher?
No, sir.
No. It is an important 8 mark or 13 mark question, man. You just go through it. Okay. Right. So next one is, shall we move further? So I hope 12 till 12:30 we have class, right? So only two things are remaining. Some three things are remaining. Is it boring one or interesting? Is
Interesting, sir.
interesting. Okay. அப்போ தைரியமாக போகலாம். சரி, okay. So polyalphabetic cipher. Next topic is polyalphabetic cipher. In this polyalphabetic cipher also, we are going to segregate our plain text into number of blocks. Okay, so here also we are going to encrypt my data, here also encrypt our data, okay, by using some other method, right? So what is a method in that plain polyalphabetic cipher is, it is also known as Virginia cipher, correct? So I already told in that first thing itself, polyalphabetic cipher is also known as Virginia cipher. Okay, just leave these all stories. Okay, so this is a table. Okay, this is a table. Again you are going to write a ABCD row wise and also column wise. You just watch it, don't write because it will take some huge time. Okay, so ABCD and ABCD. Okay, now start with that. ABCD and BCDE and CDEF. You just visualize this chart. Okay, so you just want to write in your exam also. Okay, so if it is start with B, if it is start with B, go with CDEF like that. Okay, so this is a chart, right? So in this column wise, this ABCD represents key, and in that row wise, this ABCD represents plain text. Clear? So this is a key one. In that column wise, this is a key, and in that row, this is a plain text. Okay, now you have your original data, you have some plain text. We are discovered, save yourself. Okay, we are discovered, save yourself. That is a plain text, for example. Okay, and you have a key, you are using that key, deceptive is a key you are going to use in this. Okay, so I can repeat this keyword till the plain text. Okay, so how many letters are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27. Okay, so I have how to say, so I will repeat that. Okay, so deceptive is repeat that till W to F. Okay, so deceptive means 1 2 3 4 5 6 so first 9 letters. 1 2 3 4 5 6 7 8. Okay, so for this I have a keyword deceptive. Again from over 1 2 3 4 5 6 7 8 9, for this 9 I'm again going to use this same key deceptive, and for remaining letters also I'm going to use this key deceptive. Okay, so you just write it down, you just write it like that. Clear? Okay, now I have a plain text and I have a key. So what is the first letter? D is a key and plain text is W. Okay, so go to that chart. Where is D? D is here, and this is a key. And where is W? W is there. So what is parallel to D and W? D is there and W is there. So what is parallel to D and W? Is Z. Okay,
Is that sir?
yes, yes. Now your letter has been replaced with, your letter has been substituted with Z. Clear? Like
Yes,
that,
sir.
like that you want to continue for the whole word, sorry, whole sentence. You want to continue for that whole sentence. Clear? So this is known
Okay,
as,
sir.
this is known as polyalphabetical cipher. Clear? Okay, so till now we have seen some 5 methods in that substitution technique, and the last one is one time pad. Okay, so one time pad is nothing but rotor machines. Okay, one time pad is nothing but I'll give it as an assignment. Okay, at last I'll give it as an assignment. Just write it down, and if I forget means you just remind me. Okay, so our next one is rotor machines. So how many of you have seen that film Da Vinci Code? Da Vinci Code படம் எல்லாம் பார்த்திருக்கீங்க இல்லையா? Okay, so in the Da Vinci Code Professor okay, Professor Longton, Professor Longton தான ஒரு பேரு. So he had some message, he had some box like if he rotates means if the keywords are same, if he rotates that particular keyword, the data will be shown to him. The leaf with the data which will be present inside that box, inside that roller, and that if he gives the correct key, that data will be shown to him. Correct? So that is called rotor machine. You just assume that. So this is the rotor machine. What is that? Yeah, this is the rotor machine. For example, இப்போ நம்ம how to say, நம்மளோட சூட்கேஸ் எல்லாம் வந்துட்டு நம்பர் லாக் இருக்கும் தெரியுமா? ஸோ அந்த நம்பர் லாக் கரெக்டாக அந்த நம்பர் கொடுத்தா தான் என்னோட சூட்கேஸ் ஓப்பன் ஆகும். கரெக்ட்? So this is the basic of that rotor machine. If you give that particular same number, the data will be shown to you. Okay, so this is one of the encryption techniques. Clear? So these are some of the rotor machines. These are some of the rotor machines. Okay, and now we are moving to the transposition cipher. Till now we have seen all the techniques in that substitution cipher. Now we are moving to the transposition cipher. What is called transposition cipher is, there is only the replacement will happen. There is no new letter will be substituted. Okay, there is no new letter will be included in that plain text. Okay, like substitution cipher. Substitution cipher na நான் ஒரு லெட்டருக்கு பதிலா இன்னொரு லெட்டர் சப்ஸ்டிட்யூட் பண்றேன். Transposition cipher na நான் ஒரு லெட்டரை இன்னொரு இடத்துக்கு டிரான்ஸ்போர்ட் பண்ணி வைக்கிறேன். That is called a transposition technique, right? Okay, so we have some example for the transposition technique also. It is so very interesting one. For example, row transposition cipher. So this is a key, 3 4 2 1 5 6 7. This is the key. Okay, so you want to hide your message. You want to hide your message and hide your message from the third parties. You need to show your message only to the receiver, only to your friend. Okay, so here the key is 3 4 2 1 5 6 7. Okay, so this is the key, right? What is the message here? So what is the message here is 1. Where is 1? Here. ஓகே ஸோ இதில் என்ன கொடுத்துருக்காங்கன்னு எனக்கே தெரியல. ஓகே ஃபார் எக்ஸாம்பிள் இஃப் யூ ஹேவ் சம் ஜென்ரல் டெக்ஸ்ட் ரைட், இதில் எங்கேயோ சென்டென்ஸ் வருமே.
சார் அட்டாக் போஸ்ட்பாண்ட் until 2 AM.
எஸ் அதே தான், ஆனால் அது எங்கேருந்து ஸ்டார்ட் ஆகுதுன்னு எனக்கு தெரியல. நீங்கள் சொன்ன இது கரெக்டு தான், ஆனால் அது எங்கேருந்து ஸ்டார்ட் ஆகுதுன்னு தான் தெரியல. சாரி கரெக்ட். யூ ஜஸ்ட் ரீட் இட் டவுன். நான் ரோ காலம் வைஸ் போட்டேன். யூ ஜஸ்ட் ரீட் இட் டவுன். அட்டாக் ATTACK postponed until 2 AM. Okay, and that email letter I can replace with that XYZ. Okay, so this is my original message. Attack postponed until 2 AM. So this is my original message. Okay, so by using the key I'm going to transposition my data, transport my data. So first is 3. Okay, so take this 3 column, TTNA. Next is 4, APTM. Next is 2, TSUO. Like that I just rearranged all my letters and converted into a ciphertext. Clear? So whether this message gives any meaning, this ciphertext gives any meaning? No. So this is known as transposition technique. Clear? So once that receiver got the ciphertext along with this key, he can rearrange this letter by using this key, and he can get that original data. Clear? So this is known as transposition technique. Transposition technique is nothing but just rearranging, just transmitting your data into some other place. That is called a transposition techniques. Okay, and next one is product ciphers. This is not that much level important. It is in between that modern ciphers and classical ciphers. Okay, next one is steganography. So how many of you know about that steganography? Hiding a message in another message, that is called as steganography, right? So நிறைய படத்துல வந்து இந்த ஸ்டெக்னோகிராஃபிலாம் யூஸ் பண்ணியிருப்பாங்க. ஒரு பர்டிகுலர் மெசேஜை ஒரு இமேஜ்குள்ளே ஹைட் பண்ணியிருப்பாங்க. சாரி,
இமேஜ் பின்னாடி தான், பிக்சர் பின்னாடி இமேஜ் ஹைட் பண்ணியிருப்பாங்க.
பிக்சர் இமேஜுக்குள்ளே வந்துட்டு டெக்ஸ்ட்டை வந்து ஆட் பண்ணிக்கிறது, like that. So this is a technique, steganography. Okay, so hiding your particular message into some other message or some other image, இது வந்து steganographyங்கிறது. So in this image itself I can hide some data. Okay, so we came to an end, right? So first thing, what are the things we have discussed till now? Classical cipher techniques and terminology. So in that classical cipher techniques we have two types. One is substitution cipher, another one is transposition cipher. In this substitution cipher we have some 6 types. One is substitution, and another one is transposition. In this substitution, Caesar cipher, monoalphabetic cipher, Playfair cipher, Hill cipher, and polyalphabetic cipher, one time pad. Okay, and the second one is transposition technique. In this transposition technique we have two things. One is row transposition techniques, and another one is rail fence technique. Okay, so I forgot to explain that rail fence technique. Rail fence technique is nothing but just rearranging the words without using key. Okay, without using key you are going to rearrange this. That is a rail fence technique. Okay, so I'll show you example in next class. Okay, cryptanalysis, what is meant by cryptanalysis, and what is meant by Playfair, polyalphabetic transposition, like that. Okay, so till now we have discussed all the things. Do you have any doubt in that?
No sir.
No. Okay, so now it's time to discuss. Yes, who is that? Okay, so it's time to discuss that one time pad. Okay, so I have already told it, I'll give you as an assignment now, right? You have ABCD, and also you have named as 0 to 25, correct? Okay, so take
yes,
that.
sir.
Yes, take that example, ACT. Your plain text will be ACT. T for Tamil. Okay, ACT, right? And now your how to say, your key key is CNS, cryptography and network security, CNS. Got it? Right. So in this one time pad is we can use some formula, right? So what is the first letter here? Plain text A, right? What is the first letter in key? First letter in key C. C. Okay. So what is the value for A here?
0.
0. What is the value for C here?
2.
2.
2.
Okay. So here K plus P mod 26, that is 0 plus 2 mod 26. What is the value? 0 plus 2 mod 26. If that value is lower than mod 26, you can take that value directly. I've already told, right? இப்போ 2 mod 26 னா 26 ஓட 2 வந்து கம்மியா தான் இருக்கு, சரியா? அப்போ அதோட ஆன்சர் என்ன? 2 தான்.
Yes, sir.
Okay. So ஏவும் சியும் வந்து by using one time pad ஏவையும் சியும் நான் கம்பேர் பண்ணுறேன் அப்படின்னா what will be my cipher text is that number 2 na C is a cipher text here. Clear?
Okay, sir.
Okay, what is the second
Yes,
one?
sir. Yes, sir.
Second letterல கீழ என்ன இருக்குது? C இருக்கா? சாரி N
C.
இருக்கா? Cங்கிறது வந்து plain textல second letter, கரெக்டா?
Yes, sir. Key N.
என்னென்ன இருக்கு? N-ம் C-யும் இருக்கு, கரெக்டா? Okay.
Yes, sir.
So what is the value for C here?
Sir, C is 2.
2. N-க்கு
13.
13. Add these two things. 13 plus 2. What is that?
15.
15.
15 mod 26. What is the value?
15.
15. What is the alphabetical letter for that 15?
P.
P. P.
Okay.
P, sir. P for Praveen Kumar.
Okay, you just replace it. The same thing. What is the last letter? T.
T, sir.
Yes,
19.
sir.
T அப்புறம் S, கரெக்டா?
18.
Yes, sir.
T ஓட வேல்யூ என்ன?
17.
19.
19, sir. T ஓட வேல்யூ
19.
0ல இருந்து வெச்சுக்கோங்க. அப்ப T க்கு வந்து 19 வருதா?
ஆமா சார்.
ஓகே, அப்போ லாஸ்ட் கீக்கு S ஓட வேல்யூ என்ன?
18.
ரெண்டையும் ஆட் பண்ணு.
37.
37 mod 26 போடு.
11.
What is a letter which shows
L.
that 11?
L.
L ஆ?
ஆமா சார்.
அவ்வளவுதான் உங்களோட சைஃபர் டெக்ஸ்ட் வந்துருச்சு. இதான் ஒன் டைம் பேட்.
CPL.
ஓகேவா?
CPL.
அவ்வளவுதான் முடிஞ்சிருச்சு. கிளியர்? ஓகே.
Yes, sir.
சோ இன்னைக்கு செஷன் கொஞ்சம் லாங்கா போயிடுச்சோ?
Yes, sir.
ரொம்ப லாங்கா? ஏன் தூங்கிட்டியா?